Alright, so today we're going to talk about congruent quadrilaterals. You remember that the word congruent means that the angles and sides have to be the same in both shapes, and we had talked about it in terms of triangles before. Now we're talking about congruent quadrilaterals, or four-sided figures. So we know that all the angles of one are congruent to the angles of the other one, and at the same time all the sides of that first quadrilateral are congruent to the sides of the other quadrilateral. There are two ways to prove two triangles congruent. One is side, angle, side, angle, side. That probably looks like that triangle congruence statement stuff we did with side, angle, side. And the reason why it's side, angle, side, angle, side is because you have two triangles within a quadrilateral. If you drop a diagonal, you'd have side, angle, side, which is essentially two different triangle parts being congruent. So in this pair of quadrilaterals, AB is congruent to EF, BC is congruent to FG, CD is congruent to GH, angle B is congruent to F, and angle C is congruent to angle G. So I've got my side, angle, side, angle, side. The second way to prove two triangles congruent is quadrilaterals, is angle, side, angle, side, angle. So this time I'm given that I have quadrilateral ABCD and parallelogram, ABCD and parallelogram EFGH. I know that angle B is congruent to angle F, that's given. I know that AB is congruent to EF, also given. And I know that BC is congruent to FG, that is also given. But I don't have enough information to say that these two quadrilaterals are congruent yet. I have to think about what I know about parallelograms and what I know about this quadrilateral. What do we know about the sides in parallelograms? Opposite sides are parallel and congruent. So that means that AB is congruent to CD. Well, by the transitive property, we also know that these two are congruent. So that means their opposite side is going to be congruent. All right. The same thing applies up here. BC is congruent to its opposite side, and its opposite side by transitive property is going to be congruent to the opposite side of the other one. Do I have my angle, side, angle, side, angle? Angle, side, angle, side, angle. I don't have it yet. So how am I going to get these angles congruent? In a parallelogram, opposite angles are congruent. So we've got that angle, side, side, angle. So I still have to get these two angles congruent. How can I do that? What else do you know about the parallelograms angles? These two angles, which are consecutive, have to add up to 180 degrees, right? So angle C plus angle D equals 180. Angle H plus angle G equals 180. What do we know about D and H? Yep, they're the same. So that means that C and G have to be congruent, because there was a theorem that we had a long time ago that said supplements of congruent angles are congruent. This is where all that crazy stuff that we learned in one piece at a time fits together. So now we have angle, side, angle, side, angle.